Hello again, my friends. How are you today? Now, instead of concluding this series as I thought I might, I figured there's at least one more topic that I have to go through in order to say that this is at least left you in a position where you can do something, sort of make your mark. In fact, making your mark should be part of the title of this tutorial lesson. Now, this tutorial is all going to be about the concept of serialization. Now, you don't have to look far to find that word. It's show up everywhere. So I put this on C# here. Okay, now object must be pretty basic thing. Let's see now. Okay, object. Alright. Okay. That's object. Click on this or this. Let me try clicking on this one. No, the wrong type. This. Object. I want a list. Well, that's for internet. Object class. Here we go. What's an object? Whoop. Go back there. There! See? So, the most basic thing, or the first thing listed under the most basic possible thing, which is an object, is a serializable attribute. What's that? Well, that's a visible attribute, which is an attribute usage attribute, which attribute targets class, attribute targets struct, attribute targets blah blah blah, public attribute. Serialization, I serialize. Now, I stands for interface. Okay, that's visible. Com means common object model, by the way. The most horrible thing ever invented by mankind. Custom serialization. Alright, so anyway, you can see that comes up pretty quick there. MSC. What? Here for a second. What's the most basic example of an MFC object? C. Overview. Fundamentals. Sheets. Serialization. Okay. Doesn't take long. Does not take long. Archive class, file class. Object class. Something dynamic. Information. C object and serialization. Again, serialization. Now, I also happen to have this program I installed on my system. Thanks to our buddy Bucky. I was going through his Java tutorial, and as you might guess, Java 2 as its most basic attribute of everything in Java is class. What's a class? What does it implement? Serializable. Again, interface serializable. Blah 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 blah. You see how easy it is? Nothing to it. Okay. So I figured I might as well talk about serialization since that's what everybody's going crazy about these days. And I started with this, but I'm going to start again and make a new project. And I'm going to call it Serialize. How about just Serial? Serializable? No. I don't know. How's that? No, I don't know. Why? Serialize. What does it mean to serialize? Now I've changed this back to non-Windows. So this is just console applications. We start out with our usual hello world. Looks fine. I think debug. Okay, that's good. We'll stick with ANSI for now. Okay, now that's good actually. Serialize is a good name. First I would like to point out one thing which is a problem. See this style selector thing that I made, which now has a nice icon? Well, see, I'm going through these styles, and I was looking at the extended styles. See how far down I have to go to get to the extended one? And I found client edge and modal frame, is it? And modal frame, and I applied those two extended attributes to my little horsey. And look, see how nice it is? It's got a little box around it now. So, now, next time I go in here, I want to go here. Now I gotta find it again. I'm gonna scroll all the way down. I'd like it to remember where it was, last time, and then I can resume. So I need to save off where I was. And the concept of serialization is the idea that there's some data storage area somewhere in the world. It doesn't have to be on your hard drive. It doesn't have to be a registry. It might be on a web page. It could be cookies. It could be anything. And so that this is perfect for C++. What we want is a kind of interface to saving and restoring information about the state of our whatever it is we have, program, I guess. So, to that end, I'm going to create a new file, a header file. I'm going to define an interface. I'm going to call this serial.h. This little header. And interface serialization interface. Now this here is going to be a pure interface. Alright? Struct. Gotta give it an ugly name, because it's not something you're going to want to write down. Now, I've already done this, so I've tested it, and that's okay. You just have to remember what I have now. Now, everything's going to be virtual. Everything's going to have a true or false return value. Now, first thing is connect, which will take a D-word timeout. Pure virtual function. Now, so for instance, if you're trying to save information on a website and you can't connect to your serial thingy, then you have to give up. So this is something that, in general, you're going to have to call first to see if you can connect. Even if you define properly the thing that you want, you still have to make sure that you're connected to could be a database, SQL database, who knows? Now, four functions: gets and sets. So let's do a set for set. Now usually it's numbers and strings. So I'm going to call this D-word. D-word's good enough. It's 4 gigs worth of numbers. Set D-word. Now, everything's going to have a name. Use basic types for this anyway. And then some value. Okay. And strings. Now the question here for the name, whether or not we should use our own built-in string. I think we should use our built-in string, a constant reference maybe. And the reason for that is I think well, it's the candy machine thing. You don't want these two things to be exactly the same, or else you're going to get confused as to which one comes first. Although there is an automatic conversion, hard to say. Anyway, that's good enough. Okay, and how about getting them back? Same thing, except it'll take a reference. Okay, so we connect, we can set a number or a string, or we can get a number or a string, and the name here corresponds to the identifier for the particular value. Now, this is so far pure virtual. So somebody's going to have to implement this. And we're going to implement it. I'll do one implementation. I'm going to use registry, in fact. That's why that thing, that's why I have registry here. But you could use a file, any file if you wanted, or if it's a web page thing, you can use cookies, or who knows. Next, now there's several ways of going about this. One of the things I've added to this, to our common here, is a kind of smart pointer thingy. So I'm going to use that. And I'll show you how that works in a minute. This is a type of reference counter. Okay, so that you can pass these things back and forth and not have to worry about deleting it. In fact, deleting and newing of these things will not be available to the programmer. So it doesn't have to really do anything. I've got to put it here. I got to make sure that you're not allowed to delete it. And construction, which also doesn't do anything. I'm going to define and implement nice and private. So there's no way you can make it. You can make a new one. Actually, I don't really need to, do I? Yeah, no, that's gotta be there. But maybe protected too. Hang on a second, let me check my other thing. Well, I don't really have it there, and it may not be necessary, so I'll leave it out for now. Because what are you going to do? How are you going to make a new one of these without deriving from it? Now, you won't be able to, you can't delete this. You won't be allowed to delete this. However, the smart pointer will be allowed to delete it, so we have to make that our friend. Since refs is our friend, refs has access to all of our functions. I don't know why I can't make this private, but I guess you'll see. Oh yes, now you can. Another thing you're gonna want to do with a kind of thing like this is to delete the value. Delete something from your database. Okay, now is that a complete set? Okay. Now how are you going to make one? The way one usually does it is to have a static member function, which is going to, first I need to make a type def. First I have to declare that there is such a struct called serial, and then I have to make a type def smart pointer to a serial, and I'll call that an H serial. So handle to serial, those things are things you can actually copy. Now the reason for doing it this way is, well, for one, so that you can't new one by yourself, and so that we always only have things that have are reference counted. If you were given it just a pointer to one of these objects, then you could pass that pointer around, and then the reference count could get messed up. And this smart pointer thing doesn't give you pointers to the object. It allows you to use the internal pointer through its own interface, which I'll show you. Now, what did I call it? Create instance, something like that. Hang on a sec. Okay, this is what I have before. Create instance. Now, I'm thinking of this as a type of tree-like structure. For instance, if you're using XML, this would be perfectly suited for an XML file, which has keys and subkeys, and underneath each key is what you call a namespace. So, everything under one particular part of the tree has that namespace, just like a directory structure. This is a namespace, right? This is everything of the type D source root tutorial CPP tests, right? Everything has that prefix implied here. Now when we want to create our own magic, our own special area for a special program, we want a sub key underneath that named whatever our root namespace is called, and I've actually just given names for these right here. Now, because some of you people use Unix, I thought, I don't want to mess you up and confuse you with the wrong direction / software. Okay, I know that's kind of a Microsoft thing, but whatever. Now, so let's say that now I could include in front of this more words, but whatever it is, whatever database you're putting this in, if it's an SQL database or whatever, there's going to be a section called software. Maybe there isn't, you can make a new one. If there is and it's the wrong one, you can change these values. And then you have your company name, which I called my company, and now I have two separate values depending on whether or not we're debugging or release. So when we're debugging our program, we can fiddle around with our settings without having to mess up our settings for the release version. Okay. Now, of course, this is a variable. You could alter the root namespace in any way you like, and choose the subkey in any way you like. All right. Now, is there anything else in here? All right. Now, let me just show you this smart pointer thing first. First, we'll start with refs. Refs is just a thing that counts references to something. Like if two people are looking at the same object, the reference count would be 2. Once everybody has gotten rid of their version of whatever object it happens to be, the reference count becomes 0. And when the reference count becomes 0, the thing, whatever it happens to be, gets deleted. Anything derived from a ref has a virtual destructor, so I didn't need to use the keyword in my serial thing. Now, there's a second level. In order to create a smart pointer, we need to make a secondary object which uses a ref. Okay, So something which contains a refs in it, okay, and has the usual constructor, copy constructor, assignment operator, and destructor. When we construct this with anything that happens to be a refs, as our serial thing is, the object will have its reference count incremented. This interlocked increment is just a thread safety thing. If two threads happen to try to increment the same value at the same time, you get a crash, so that avoids the crash. Now, copying a ref pointer one from another constructing from another object will set our object to his object and increment the reference count. So a copy construction bumps the reference count up. Assignment is slightly different. If we already have an object, we have to decrement our reference count, assign the new object, and then increment the reference count of the other one. And when we die, we decrement our reference count. Now, smart pointer is derived privately from ref pointer and can take any class as its template argument. It has an operator arrow which returns a T star, so I kind of lied about that. You can get a T star out, but you got to work at trying to screw things up. We cast the object to a T star. When using the arrow operator, we simply return a T star version of our object. There's a star thing, which I never use, but if you want to look at the object as a reference, instead of using arrows, you might want to use dots. There's a not, kind of useless. Is null is more useful. That's what I always use. This I added later on because sometimes for debug tracing you want to know how many references there are. And that's all there is to a smart pointer. And this thing returns a smart pointer to a serial. Okay, I could have typed all that in here, but I figured I'd make the type death. Okay, so now it's time. Well, first let's add this. I'd actually rather call this main.cpp. There we go. All right. Now here's the intention. This is what we want to do. H serial H my data area equals serial create instance. No, not I want to choose a name for a special place for my program, and Well, I'll take the default for that. And then I might do something like this. Set viewer. Now I have to give a name for these things. Set viewer value and give it some number 23. For this fine success. And I might want to set a string. How about I can use one of these. That's what everybody likes to do. Now I know that's going to be the program name. So success, keyword, success, string. Now, let's say we can use the arguments. So if there's no arguments, we'll do the put or the setting. Doesn't matter what the argument is. Then we'll try and see if we can read them back. Now, in this case, I give a keyword. Unsigned value. Character tone. Character trees. Now we need a string. I did like this time I have to be careful. It's T, it's printf, C, and printf. Not so bad. Now, this is all there is to Serialize, by the way. There's nothing more to it than this. Now, of course, I can try and compile this. Oops. And I don't have any syntax errors, but, well, for one thing, we're missing this. We don't have the create call. And now I'm going to use the registry. Let's see how much time I've used that. Okay, so I'll let that be part one of serializing. This is the idea. This is what you would call an interface. Okay. We don't need to know anything about how or where the data is going and where it's coming from. There's always going to be some kind of static member that's going to make that decision. That's where the decision is made, for what type of implementation, what the implementation is. But that's none of our concern. The object that we receive back is an object which is a smart pointer object, which means we can pass it to any function, or we can put it in a struct or whatever we like, and it will eventually go out of scope and it'll delete itself automatically. We're not allowed to delete it. That's protected. But the smart pointer will take care of that. Okay, so till next time. Whoops, I almost forgot, and I actually didn't implement this one. There's one more to complete the list. Some kind of binary. And I guess we would need, since we don't have a buffer class, we'll have to say a pointer void data and size type. Use a D word for. I wonder if I could use a D word for the size. Well, it doesn't matter. I think we can do this. That is, when we get this, we will pass a p void to the function, a reference to a p void, and a reference to a size, and this p void will come back full of data with this size set, which we should be able to retrieve. Since we've set it, right, we can retrieve both of these things. And now the question is whether or not we should do that. We should not be doing okay, now this is going to have to be allocated somehow. So there's a couple ways to go about it. One is we could tell the size first and ask them to put in a buffer of the correct size, or we can do it this way and provide some way to release this data, because we might not use malloc. It might be on the internet, it might be global using global alloc, or or heap alloc, or some God knows what. So either they got to do the alloc or we got to do the alloc. So that's a question of how about we just have one more virtual. It sort of goes along with this delete, but it's not the same. This one can't really fail, but can't default delete. But then somebody might try and free it, you know. If only this were a struct of something, right? This has got to be a type of handle. Like that. Okay, if this is not a handle, that's just a regular old pointer. Now, in order to get the data out of the handle, we would have to provide some kind of lock mechanism. That was locking. So if it was movable data, that would keep it from stop it from moving around, and then that would get the data, and this could be passed in the sun. Oh, it's getting too complicated. Okay. Let's just do the simplest thing then. And this will be a malloc pointer, but we'll still provide a free function. Free a pointer. And that we'll just call free. If we use malloc, we'll call free. This is actually necessary because even if you're able to read this data, it might have been malloc using a different runtime library. For instance, if it's in a DLL, right, it might be using the DLL runtime, whereas we're using the static runtime, and they have their own version of malloc. So that if we tried to free it, it would get a crash because it doesn't belong to us. So we got to pass it back in to be freed by the person who created it. Okay, now there's our interface. Next tutorial, I'll make an implementation using the registry.